Hello everyone, this is Professor Robert Solis. Welcome to this next video lesson. We're still talking about the recursion capabilities, or recursion I should say, in C++. And let me just run this program to give you a demonstration of what we're going to do. We're going to ask the user to enter how many Fibonacci numbers they want to display. And as you'll recall, the Fibonacci series is the first two numbers are 0 and 1, and then you add the previous two numbers to get the third. So if I said give me 10 Fibonacci numbers, so 0 plus 1, the first two gives you the third. Okay, the previous two gives you the third. The previous two gives you the third in terms of adding them, right? So 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, so forth and so on. So the user is going to let us know how many Fibonacci numbers they want to see. And the way that we want to perform this task is using recursion, which is this function right here. So you've seen from the previous videos that recursion is a function calling itself. We must have a base case, and in this particular instance we have two base cases. And so what I have done is to create this graphic so that I can explain to you what's going on. Now, if the user says, I want to see one Fibonacci number, well, that first Fibonacci number is going to be 0. If they say, I want to see the second Fibonacci number, well, that's going to be 1, because 0 and 1 are the first two Fibonacci numbers. Then if the user says, I want to see 3 Fibonacci numbers or more, then we start really seeing the advantage of the Fibonacci series. So first let me start off over here with this. Let me show this and not show that. Okay, good. So the user says, enters 1, right? So let me just type here the number 1. I want to see one Fibonacci number. Okay, if Fibonacci number is 0, no. Else if Fibonacci number is 1, yes, return 1. Okay, and that's it. That's the end of this particular call. We don't call the Fibonacci number or the Fibonacci function again because we just returned 1. This is one of the base cases. How about this? Let's say that the user sends us the number 1, or the number 2, I should say, right? So number 2. Okay, so they send us the number 2, meaning they want to see the second Fibonacci number. All right, well, wait a minute here. It says here, if Fibonacci position is 0, yeah, that's right. What is happening here is, let me just undo. Here we go. Based on the Fibonacci number position, so 0 position means the number 0. Number 1 position would be the number 1. Number 2 position would be the number 2. Number 3 position would be the number 3. Because, in other words, when I run the program here, maybe it's easier if I just describe it like this. This is position 0, position 1, position 2, position 3, position 4, 5, 6, 7, 8, 9. All right, now there's 10 positions if I started from 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But you know how we computer scientists like thinking or starting numbers counting from 0. So this would be, you could think of this as, it's not an array, but you could think of this as index 0, index 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's going to give us the location or the position of the number that we're looking for in the Fibonacci series. All right, so let's jump over here to this guy over here. Let's see what happens if, let's go back to the program over here. How many Fibonacci numbers do you want to display? All right, so let's say that the user enters, I want to see 4 numbers. Okay, so if they want to see 4 numbers, we're creating a counter that starts at 0. As long as 0 is less than 4, so that means that we're going to go through this loop. 0, 1, 2, 3. That was 4 iterations. And that makes sense because the user wants to see 4 Fibonacci numbers. Let's run the program. 4, enter, 1, 2, 3, 4. So we start this loop starting from 0, and watch this. 1 lap, 2 laps, 3 laps. Okay, so as long as our counter is less than the user number, we keep on looping. Well, since we started 0, and let's say this is 4. So 0 is less than 4, 1. 1 is less than 4, 2. 2 is less than 4, 3. 3 is less than 4, 4 loops. So we're going to go through this 4 times if the user enters the number 4. Makes sense. And every time we are calling the Fibonacci function, and what are we doing? We are giving the position, which is really we're sending the letter I, whatever the value of the counter is. We are sending it the position of the number that we want. So give me the Fibonacci at position 0, or position 1, 2, 3, 4, 5, so forth and so on. And then I can solve it. If it happens to be the position is 0, I return 0. That's the first number. If the position is 1, then I'm going to return 1. Now, if the position is 2 or more, then we're going to go to this else statement. And so this is where I want to use this graphic to help us describe what's happening. So let's say that I have position 3 here. Okay, so over here, if I replace this with a 3, okay, so we're going to call this function with the number 3. Well, that's not 0, and that's not 1, so that means I have to go to the else statement, and notice I have 2 individual Fibonacci function recursive calls. Here's the first one, here's the second one. So check out this strategy of sending it whatever the number is minus 1 and whatever the number is minus 2 in 2 separate procedures. So let's go through this. We'll follow this over here first. So if I'm sending you the number 3, so I'm going to type in a number 3 over here. That means I'm sending the Fibonacci 3 minus 1. Okay, so I'm sending you 3 minus 1. So over here, this is going to be, I'm sending you 3 minus 1, which of course you know is 2. Is the Fibonacci number 0? No. Is it 1? No. Okay, so then that means I have, over here, I'm sending you 2 minus 1. I'm going to call the Fibonacci, and I'm not considering this one yet. We will in just a moment. I'm sending the Fibonacci function, a recursive call, 2 minus 1. Okay, so that means I'm going to go over here. I'm going to replace this with 2 minus 1, which of course is 1. All right. If the Fibonacci number is 0, nope. If the Fibonacci number position is 1, yes. Yes, because 2 minus 1 is 1. That's true. So what do? We return 1. So let me see if I can write over here. So this whole thing right here is replaced with the number 1, because that's what's returning. We're returning 1. All right, how about over here? Now, let me return back to this. All right, so 3 minus 2 was sent to this Fibonacci function. So 3 minus 1 rather, so that's going to be 2. So that means this number is 2. So I replace that with the number 2. So it looks like I'm calling the Fibonacci function with 2 minus 2, right? So that means I go over here. Whoops, sorry, I meant to do this. And this whole thing right here gets replaced with a 0. Because 2 minus 2 is 0, so call the Fibonacci function. Oh, here you are. And send it the number 0. Okay, here it is. Well, what does that mean? If Fibonacci position parameter is 0, yep, you gave me a 0, so therefore return 0. Okay, so that means that this whole thing over here becomes 0. 1 plus 0 equals 1. So that means that I am going to be returning the number 1. Okay, so let's go back to who was calling me. Ah, this guy over here was calling me. So this whole thing becomes the number 1. Okay, all right. Let's take care of the other side now. So the Fibonacci number was 3, because that's the position that I'm looking for. And by the way, just like position 0, position 1, position 2, position 3, right? Position 0, 1, 2, 3. The number should come out to be 2, because that's the 0, 1, 2, 3 position. All right, let's see what happens here. Fibonacci, I gave you the number 3. Okay, so this right here, I can just replace it with the number 3. 3 minus 2 is 1, so I'm really sending 1 to this recursive Fibonacci call. So that becomes 1. Is the Fibonacci number 0? No. Is the Fibonacci number position, I should have been saying, is that 0? Yes, it is. Or 0. Is it 1? Yeah, here it is, 1. Okay, so that means that I'm going to return 1. So what happens over here is This guy over here is 1. Now, is there a call to these other? No, because in this case I just sent it Fibonacci number 1, so there is no call. In fact, I shouldn't have really put those here. Get rid of this, get rid of this, get rid of this, get rid of this. Because if you're sending me 1, well, then I'm going to return 1, so there is no additional call. Only on this side was there, let's see what, 3 minus 1, that's going to be 2. Yeah, there it is, 3 minus 1 is 2. So that's not 0, it's not 1. So that means over here, this is where I had my Fibonacci recursive calls. So now that I am done with my Fibonacci recursive calls, I am going to return 1 plus 1, which of course equals 2. So this thing is returning 2. And then finally we're done. And that's exactly what's supposed to happen. You're supposed to give me the number 2. Because in position 0, 1, 2, 3, that number is supposed to be 2, which is over here. Okay? So that's how this function works. We are going to be recursively calling it. And again, the beauty of this approach of calling the same function 2 separate times on the same line, really what you're doing is you're doing this. You're saying, okay, add the previous 2 numbers. That's really what is being expressed here with this function call. So add the number prior to me, and add the number prior to me. Put another way, if I'm trying to figure out this number, okay, add the number that's prior to me, and also add the number that's prior to me. So add the number that's 1 space before me, add the number that's 2 spaces before me. That's really what this is doing. And as a result of that, we can determine what the previous 2 numbers always are, no matter how big our Fibonacci series gets. So let's say, for example, that I draw this out. So 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. All right, so let's say that I want to get the next number. Okay, well, first of all, you're going to say solve for the, or get the number before me and get the number before it. And what are we going to do? Add them together. So that means that this is going to be 13. So this function is very clever. And it'll just keep on going on and on and on for however many Fibonacci numbers that the user wants to see. The beginning part of the program is pretty easy, just simply asking how many they want to see, put that into user number, and then I have a for statement. So that for statement is basically going to keep on calling the Fibonacci function because I am displaying individual Fibonacci numbers for however many that the user wants to display. So if I said 5, then that means I'm displaying 5 Fibonacci numbers. If I said 10, I'm displaying 10 Fibonacci numbers in this series. So that's why I put this within a for loop. I use int I to create a counter called I, and so I is going to be 0, 1, 2, 3, because you can see it's being incremented by 1. As long as it's less than the user number, keep on doing this. And what do? I see out whatever the value is of that 0 position Fibonacci number, then the 1 position, then the 2 position, then the 3 position. And I add a space after that, so I just get a string of Fibonacci numbers. And then that's it. All right, so this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.